The last video in the waves unit is going to be on two things, dispersion and diffusion. They sound the same, and they sound kind of like reflection and refraction and diffraction. So it's vocabulary, and we got to keep track of which is which. Dispersion, to disperse means to spread out. So dispersion is when white light is spread out into a rainbow by refraction. And I think pretty much all of us have seen something like this. If I have a prism and I have white light, white light is a mixture of all the colors coming to the prism. It's going to hit this surface, and then it's going to refract because it's changing from air into glass, and it's going to bend. But what happens is each of the colors has a slightly different index of refraction, so each of the colors are going to bend a slightly different amount. So we're going to have red up here, and then violet down here. So we're going to say that the reason why this happens is because each color has a slightly different index of refraction. Remember, index of refraction is n in the glass. So if we think of Snell's law, n1 sine theta 1 is n2 sine theta 2, if all the n2s are slightly different, then all the theta 2s are going to be slightly different. So each of the colors will bend at a different angle. As an aside, we notice this for diffraction as well. Diffraction, bending behind a barrier. If there's a hole in the barrier and we shoot white light at it, the red light is going to bend a little bit more than the blue light because it's longer wavelength. This is actually the opposite. When you're doing the refraction, the red light's going to bend less than the violet because its index of refraction is going to be a little less than for the violet. So the rainbow is backwards compared to what we saw for diffraction. The next one is diffusion. When I think of diffusion, I think of the word diffuse. Okay, which kind of means unfocused. And we're going to differentiate it. We're going to do regular reflection. And then over here, a diffuse reflection. In a regular reflection, if I have a flat surface, a light ray coming in like this is going to bounce out like this, okay? And the angle of incidence is going to be equal to the angle of reflection. Now, if I have a whole bunch of parallel lines coming in, they're all going to bounce out at the same angle, and they're going to be parallel when they come out like this. When this happens, you can form images. And we're going to talk about images more in our next unit, the optics unit, but basically it's reflection. So mirrors do this, and I can see myself in a mirror, I can see my image, my reflection in the mirror, because it does regular reflection. Diffuse reflection is when I have a rough surface. Now it may not look all that rough to the naked eye, but on a microscopic level, it's going to be rough. And light that comes in parallel is going to end up hitting each of these points at a different angle because this isn't a smooth surface. So this one might bend up this way, but then this one looks like it's hitting kind of straight on, and it bends bounce back like this. This one might bounce back over this way. So they get mixed up. They don't come out parallel. And in this, you will have no image. Now, an example of that is something like the white piece of paper. Okay? Light is reflecting off of this. That's why we can see it. And in fact, all of the colors are reflecting off of it. White light is coming from the lamp in this room. It's hitting the surface and reflecting off. But because it's reflecting off like this and getting scattered, we don't see a nice image. Okay? Now, there can be diffuse reflection. It can also be diffuse transmission going through. That might look something like this. Okay? Regular transmission, we might call it, might look something like this. Okay, here's my surface. I might have glass over here and air on this side. And light that comes and hits it is going to bend, but the rays that come in parallel are going to bend the same amount. So like this, and this is going to be regular transmission. Rays that come in parallel go out parallel, and again, you can form images, you can see things. This is what happens with regular clear glass. I can see through the glass, I can see what's on the other side of the glass. Okay? If the surface, again, microscopically is kind of rough, then the rays that come in parallel, when they refract through, are going to refract in all different directions, and maybe something like that. This would be a diffuse transmission. And I could see the light coming through, but I couldn't see an image from on the other side. So this is like a window shade. Okay, you can see some of the light coming through, but you can't see what's on the other side of it. So in this unit, we've covered refraction, reflection, diffraction, dispersion, diffusion, and they all sound kind of the same, so you have to be very careful with the vocabulary. So what you'll learn today is that dispersion is splitting white light into its colors by refraction, and diffusion is unfocusing the light because it's either bouncing off or being transmitted through a rough surface, and the light is getting scattered.